First of all, I welcome Dr. Nishant Sharma, sir, who is present in this session.
Thank you, sir.
Dr. Nishant Sharma,
Yes, sir.
today we have with us who is very dynamic, passionate and versatile entrepreneur, industrialist, renowned business leader and philanthropist as an expert of this session. Dr. Nishant Sharma has earned his BE in Chemical Engineering from G.H. Patel College of Engineering, Vallabh, Vidyanagar, and has earned Master in Rubber Technology from LD College of Engineering, Ahmedabad, and his doctorate in Business Management from Peace University. He has passionately envisaged and set the objective of innovative products for the betterment of the human race, and for that he is dedicating all his efforts towards the fulfillment of this objective by playing on various forefronts as a Chief Executive Officer of Nishant Group of Industries since 2005 and SIDSAL Biofarm Industries since 2006 respectively, and also iOS developer with Apple Incorporation USA since 2006 onwards. And he is also extremely proficient in the skills side pertaining to the innovation, knowledge and research ideas. Dr. Nishant Sharma is currently working as a CEO of Nishant Group of Industries since 2005, where he looks after all the operations of the groups and technically and commercially. And he is also working as CEO of SIDSAL Biofarm Industries since 2006. And he is founder and promoter of SIDSAL and has nurtured the company from a small to a large manufacturing unit with 460 products under the belt. The company's products list is from specialty chemicals to biotechnology and farm machineries and rubbers to home and personal care. And he is also a versatile iOS developer with Apple Incorporation USA since 2016. The sir is also recipient of prestigious award of National Business Leadership and Janseva Sadbhavna Purushkar, and a humble philanthropist and trustee at Judea Charitable Trust. So I welcome you, sir, on behalf of this STTP organizing committee, BBIT, and all participants. And we seek your coordinations and interactions for your views and experience on energy conservation and sugar industries and distillation process. So I request you, sir, please express your valuable views and experience on this today's topic. Dr. Nishant Sharma, sir.
Thank you very much, sir, for asking me to come over here and present the things that have been in the industry since so long time. And now we will be going to a presentation, a small presentation, so that you can understand presently what is there in the sugar industry. See, the first thing is sugar industry is one of the industry in India which is having each and everything, you can say, in an ideal conservation manner. Am I audible to everyone?
Perfectly, sir.
Yeah. So
Yes,
if you want to see a video, we will proceed with the video so that you can get the outline of how a sugar industry works.
Sir.
And then we will come back to the presentation. And from there, I will be telling you each and every point.
Okay.
Is it okay?
Yes, sir.
Okay.
Yeah.
Please share your screen, sir.
Yeah, sir, sure. Can you see it?
Yes, sir.
So your presentation is not okay.
Can you see it, sir? It will take 2 seconds of gap.
Yes. Yeah, it's visible, sir. No issue.
It's visible? So shall I start?
Yes,
Okay,
sir.
Yeah.
Please.
Now this is a small animation for the sugar industry so that you can get a brief idea how the process is done. And then after this, I will go to the particular process, particular flow charts from where I can explain you each and everything that how a sugar industry is one of the ideal industry in India or abroad for conservation of energy and management. Okay, now I start the video.
Excuse me, sir. There seems to be some audio problem.
Yeah. Just a minute. You are not able to hear it?
Yeah, sir. We are not able to hear it. We can see the video.
Okay, just a minute. Because from here now the audio is audible?
Your voice is audible.
My voice is audible. Now you
Ah,
check out the video. Now it stopped.
yeah.
Yes.
Yeah.
Now can you hear it? Now is it audible?
No, sir. It is not audible.
Because here it's been audible. Let me do one thing. Let me turn on my camera.
Ah, your voice is perfectly audible. No, but that video is not running.
Just a minute. Now it came.
No, sir.
Okay, let's do one thing. We will go direct to the presentation, and from there I will be explaining you each and everything. Because
Okay.
on my end the video is running, the voice is audible. I don't understand why on that end it's not.
Okay, sir. No problem.
Yeah. Now we start with the slides. Energy conservation and management in sugar industries and distilleries. So you all may be knowing about sugar canes, sugar. We are eating each and every day. Okay, three types of sugar we eat. One is tornado, the other is brown sugar, the third one is the refined sugar, or we can say white sugar. You can interrupt me in the middle if you don't understand anything. Is it okay?
Sure. Sure, sir. Yeah.
Okay, sir. Thank you.
Now we are here to save the world. What are the things we can do to save it? We will be doing, correct? So with conservation and the management for the energy saving, we can do many things that will be helpful to the future generation. Now this is some small posters so that we can enhance ourselves and we can go into that mode of energy conservation and management. Now here comes the first flow chart.
So your slide is not running. We can see only first page.
It will
only.
come. It will come.
Okay.
Actually, there is a gap of 2 to 3 seconds in the slide.
Time lag is there.
Yes, time lag is there. Now it came.
No, sir.
Which slide you are seeing? First slide still?
First
First
title
slide,
slide.
energy conservation and management in sugar industries and distilleries.
Now you
First one.
Okay. Now second one, it is out. Can you see it?
Yeah, good morning, sir.
No.
Sir, I think what
Yeah.
you need to do is you need to stop presentation and then select present screen, and then from there select yeah, that select your entire present your entire screen and then run the presentation.
Just a minute. I have done the same thing.
Okay.
I have done the entire screen itself. I am stopping the presentation over here. Okay. And we are going again to your entire screen. Is it okay now? Now,
Yes, sir.
second slide
Yes.
is
Okay, now.
Yeah, we are seeing
Let's
the
save
slide
the world
that let's
together.
save the world together.
Yes.
Yeah, can you do plus and minus so that we can see whether it's dynamic or not, the
Yeah.
presentation. Right?
Can you see it?
Can you go ahead because we are still seeing the slide one only. Let's save the world.
Second slide.
Okay. Now?
Okay, now it's
Yeah, yeah.
dynamic. Now we are
Perfect.
Okay.
able to see
Okay.
the slide that is energy conservation and management.
Okay. Okay. Now. Can you see the video?
Yes, yes,
Okay.
Yes.
Now is it okay?
yes.
Now just
Yes, yes, sir.
voice. Was it audible?
No, sir. I think the video probably this video requires a lot of data.
Okay.
So I think that is the reason. I think
It is not-
the voice is we are not able to get the voice.
Okay.
So
Now
what you can do is you can share the video to us and we can
Yeah.
yeah we can give it to the participants so they can view it on their phone afterwards on their
Done, sir.
devices.
Done.
Okay.
Okay.
Yes, yes,
Now-
that would be better.
Yeah. So now here comes the first flow chart. Are you able to see it?
Yes.
First flow chart.
Yes, sir. Yes, sir.
Yes, sir. Yeah.
And can you see the arrow I am marking over there?
Yes.
Okay. Now let's start. See, what happens over here with the sugar industry? A sugar cane is grown and in the fields. And when it is threshed and it's taken to the mill. Okay. So each and every time we don't need to plant a sugar cane. A sugar cane is such a plant that it planted itself. Because in the first season, suppose if you plant a sugarcane today, and after 6 months, when you're harvesting it, the time you will cut the sugarcane, you are not going to just get it out from the roots. You will be just cutting it. And the size of sugarcane grows from 10 feet to 30 feet. If the sugarcane quality is a different thing. Okay. Now, after taking it to the mills, the first process that comes in the system is the sugarcane is being sent to the fiberizer. What is fiberizer? Fiberizer is the place where the sugarcane, the extras comes on the sugarcane is being cut. And after that cutting, the elevators take the sugarcane to the milling portion where you can see 3 rollers. If you want to see, I can just take the slide to the third one. Can you see here? Hello?
So
No,
we
sir,
are
it is
seeing.
still the same flow chart.
You didn't see the third
Yes.
one?
Yes, now it is
Yes, yes.
visible.
Yeah.
It's
Okay.
visible.
It is visible. Okay. Now you can see the harvesting is done. Okay. The transportation is done. And this portion, which we call shredder, this is the fiberizer. Actually, this is the fiberizer where the scums are being removed from the sugarcane. And then the sugarcane is taken for the milling train. Can you see the milling train? Here there are 3 rollers, 1, 2, and 3.
Yes.
The feed roller, the pressure roller, and the discharge roller. Now there are these are called 4 mills. The first mill, the second mill, the third mill, and the fourth mill. Okay. Now what happens over here? The juice has been extracted from these mills. Okay. And the juice has been sent to the storage over here. Abab, you will ask that where does the residue goes? The bagasse goes to here because the bagasse will be used as a boiler fuel. So after the juice goes over here to the storage, the bagasse goes to the boiler house where it is being used for doing the boiling as a fuel. Now this storage where the juice comes, the juice has many impurities in it. So many impurities. So we have to, first of all, we have to clear the impurities. So we take this juice to the clarifiers where we add certain amount of chemicals to clear out the juice. But those chemicals should be only of food grade. You cannot use any other chemicals rather than food grade. So in the clarifier, the clarification has been done. And after that, the juice again goes to the evaporators. Now, why the juice goes to the evaporators? Because again, almost from 100% of sugar cane, we only get 6 to 10% of sugar. So as soon as the juice travels from storage to the clarifier and it has been clarified with certain chemicals, the volume of the juice decreases because the extra water that has been used inside, or the water that is been with the sugar cane, that is inbuilt in the sugar cane, that's been get discharged from a different panel. Now in the clarifier, the juice goes to the evaporators, where the first body, you can say, this is the first body. Okay, this is called a vapor cell. Now in this vapor cell, there are vapors and this steam comes from the boiler to the evaporator. So we are again doing a energy management. The first management was done when we crushed the sugar cane in the milling and the bagasse was used as a fuel. Now the same boiler is providing steam to the evaporators. The first body is called vapor cell. Here the juice is being boiled so that it can get converted into syrup. Now the juice boils at the vapor cell. This is the first evaporator, then goes to the second, then to the third, and then to the fourth. Now these evaporators are called quad evaporators, or if they are 5, then they are called quadruple. So the first evaporator, which is vapor cell, from this the steam goes to the inlet of second evaporator. Means the first evaporator steam is being used as the inlet for second. Again, the second outlet is being used for the third. Again, the third outlet is being used for the fourth. So this way the energy is being conserved. We don't need to add other energy. The same vapor is being used. And after that, when the syrup is ready, it goes to the vacuum pans over here. And you can see a small portion of here. This is a condensate. From this vapor, what is the condensate left out? The water that is left out, that will again go to the boiler feed. It will be again used as a boiler feed because it is the purest form of water from which the boiler can be worked. Now, can you hear me all?
Yes, sir, perfectly.
Yeah. Now from the vacuum pans, again, there will be a boiling at the pans because syrup has come, okay, but the sugar has not yet come. So in the vacuum pans, the boiling will be done, and from the pans, some sort of mud is being separated. The mud that comes with the canes from the farms. So the mud has been separated and the mud has been sent to a certain land or the area itself in the sugar factory for further usage as a fertilizer. Now after from the this vacuum pans, further it will go to the crystallizers and centrifuge. Okay. While they are in the vacuum pans, there are 3 maskets. First, a masket A, masket B, masket C. Now what are these maskets? The masket A has the highest sugar content, the masket B has the medium sugar content, and the masket C has the lowest sugar content. This is ideally the last process of a sugar juice. Now from there, if you are taking a masket discharge, the discharge is called spent wash. That is also, you can say, the byproduct or a residue of the sugar industry, which again will be used in distillery as their inlet product. So the first masket A, then B, then C. In the C masket, there is least sugar present. So after the C basket, the sugar juice is converted into the syrup with a higher Brix, almost around 90 to 93-degree Brix. Will go to the centrifuges, and in the centrifuges it will be added, the other sugar crystals will be added so that the liquid starts getting converted into sugar crystals. It will go to the crystallizer where a different kind of sugar will be converted from different size. You can say large, medium, small. In India, we get small size to eat. Large size has been exported and medium size has been used by big companies or hotels to repack and again export it. Now, after that, the sugar has been ready. We will go the residue, the bagasse, the boiler ash, and the mud that has been all separated. Can you see the second chart?
Yes, sir.
Okay. Now, over here, you can get an overview from we have taken 100% sugar cane, and at the end, we get 6 to 10% of sugar. So where is the rest things gone? So over here, we need to add a water in the starting for milling. Bagasse has been gone to bagasse, the losses has been gone. You can see raw juice that we discussed, from mills the juice comes. Again, it goes to the clarification station where it's been clarified, mud and filter cake has been separated. Again goes to the evaporation station where it has been evaporated. Then the raw juice and concentrated juice, which comes to the crystallizer and centrifuge where the molasses is been separated and the sugar is been ready to be packed. Now let's go over here. This is again a small system. You can see cutting, shredding, milling. Why I am repeating all this thing again and again, so that it get hammers into your mind and you can understand what a sugar industry and where and how they are managing their energy. Now from here you can see cutting, shredding, milling, bagasse. Bagasse goes to the boiler. Again, the energy management has been done, and the wastage is being used for something to do best. The boiler runs the turbines. The turbines generate the energy because the sugar factory has its own power plant. So they don't need energy from outside. Now, the same boiler steam is used in the evaporators, juice clarification. From here, the vapor condensate goes back to the boiler so that it can be used as the feed water. Again, in the pans, the molasses goes to the ethanol distillery, and the rest dry sugar is been ready. Now, I would like to ask you some questions on which step you didn't understand or what you are going to tell. Can I get any feedback, sir? Am I audible?
Yes, sir. Yes, perfectly.
Yeah. So
Yes, sir.
now you can ask me, sir, any questions regarding this where you didn't understand the process so that I can elaborate each and everything again.
I think, sir, it's okay till the point.
But if you need to understand, because we are doing energy management, did you understand where the energy management goes in sugar industry?
Yes, sir.
So over here, what we are taking from the nature, we are giving it back. The sugar cane bagasse can be used as a boiler feed. The ash of the boiler is added with the mud from the vacuum pans and clarifiers. And again, the spent wash, which has been removed from the distilleries, because after sugar is been ready, the molasses goes to the distillery, where the molasses is fermented and converted into alcohol, and the spent wash is used for biocomposting in addition with the press mud and the boiler ash. So sugar is the only place where the whole cycle from plantation of a sugar cane, harvesting, sugar production, ethanol production, and again the same fertilizer will be used back to plant the other sugar canes. Now, sir, it's time for you to ask me what you didn't understand.
Sir, the product we get from distilleries, where does it go directly?
Directly, the product means that in distillery, actually in distillery you get rectified spirit.
Yes, yes.
Okay, RS. What we say RS. You might be knowing that there is a brand coming RS, which is sold by Kingfisher.
Okay.
Okay, generally normally market में RS ही मिलता है. Royal Stag जो हम बोलते हैं ना, that is none other than the first portion of rectified spirit.
Okay.
ठीक है, तो after the ethanol has been ready, the rectified spirit is ready. It has different process for after fermentation. If एक process में जाता है that goes to the making of whiskey, one goes for the wine, because there is not only sugar cane that is used for making sugar, even sugar beet is used for making sugar, and again the corn grain, makai, is also been used for making alcohol. So there are all different processes. In India, we are using sugarcane plants. Out of India, in US, they are using sugar beets, the beets which we eat in our salads. Even sweet potato is being used to make sugar. The product that contains starch can make sugar. And again, the question was, ये जाता किधर है? So it goes to the different distilleries that are transforming this rectified spirit into wines, whiskies, single malt, double malt, scotch. This is the system. Okay. One more thing. What is a single malt? A single malt is a whiskey that has been made in a single distillery. आज मेरी suppose a distillery I am owning, and in that the rectified spirit is been made, and then the same distillery itself, that spirit is been further processed to make the whiskey that is called single malt. Double malt comes when you are a original manufacturer of that whiskey, but you buy the ENA, extra nutrified alcohol, natural alcohol, or when you buy this ethanol from some different industry.
Okay. Okay.
Now you know how we do biocomposting?
No, sir.
Yeah. The first of all, when you light the boiler.
No, sir, no.
The first of all, when you light the boilers, the boiler produces ashes. Okay, because we are burning bagasse. So that ash is again a headache for sugar industry. So that ash has been collected and kept on some open areas. With that, the press mud that is coming after clarification and pan boiling, that press mud is again mixed with it. And finally, after distillery, the spent wash that has been taken out is being used in mixing with all these three materials, and then kept it almost for around, with an enzyme added to it, kept it almost for around 10 to 12 days. After a rigorous mixing, it gets converted into fertilizer. And that is the purest form of fertilizer, because the spent wash, which is been hazardous for the environment, has the best micronutrients contained in it. So again, this fertilizer is being made from the waste of the sugar industry, which is again used for plantation of different sugar canes.
Okay.
Now, so tell me any further questions of yours.
So we are still understanding the minute things you are mentioning. Since for us,
Yeah.
this is first time we are hearing all those details.
You can ask me any of the portion. You can ask me if you want something more into details.
Okay, sir.
See, now see this chart. What you can understand from here.
Sir, can you tell more about press mud? You had some mention, na? Press mud.
Yeah, so press mud is what? When we do the clarification, mud that is in the farms that comes along with the sugar cane.
Okay.
Okay, that comes along with the sugar cane, and after the juice has been, the milling has been done, the juice is coming for the clarification. We are settling that mud by addition of certain flocculants, because we cannot take that mud into the evaporators. Otherwise, the evaporator, when in the evaporator, the juice is being circulated in the tubes. If that mud comes into the tubes, it will be choking, and you have to clean it. Then again, the heat transfer there is a loss in the heat transfer. So there is a loss in the production, loss of energy. So press mud is being clarified in the clarifiers, and that press mud is taken and further used as a fertilizer, because it is being enriched. You can understand one thing, when sugar cane is planted, the people or the farmers, they add fertilizer to it. That fertilizer itself is present in the sugar cane. So the press mud itself has certain properties of a good fertilizer. Did you get me?
Yes, yes, sir.
Yeah. See, sugar industry is one of the industry
Yes, sir.
which doesn't buy anything from anyone. उनका खुद का गन्ना है, फार्मर्स का खेत है, देन खुद का इलेक्ट्रिसिटी पावर जनरेशन है, ठीक है, 65% वो लोग यूज करते हैं, 35% गवर्नमेंट को भी बेचते हैं. They have their own sugar, they sell it to the government further sells it to us. Again, they have their distilleries from which they make rectified spirits, and again they bottled it with nice flavors, smell, and different malts. Again they sell it, and again their residue is been further used as a fertilizer. So it's the best industry in the world from which we can earn and we can be on a renewable resources.
Very nice, sir.
Again, one thing, when the management system comes, you can see this boiler.
So I understand there are many byproducts,
This
right?
is
We can also be used
a
parallel.
boiler in which the capacity of the boiler is around 25 to 45 kg per centimeter square, the pressure. Okay. When the water, this is a water tube boilers, because high pressure boilers are always water tube boilers. You must have studied in the mechanical engineering, there are fire tube boiler, IBR and non-IBR. Correct?
Yes, yes.
Yeah. So these all are IBR boilers, and when the water, even we get that water also from sugarcane itself, because 100% of sugarcane has contained 10% of sugar only. The rest is water and mud which has been inside it. So that water again is been after the milling and clarification, that water is again been used for boilers. So if again in that water, if some impurities come, that's why we are getting the water from evaporator condensate. This is the last portion, a small portion over this here, it's a condensate. From here, the water of pH around 7 to 7.5, which is almost a neutral pH and very good for the boilers, as we don't need to get some RO or DM plants further. So this water is again used in boiler. If someone is using a raw water in the boiler, the tube gets scaling because of high level of different salts present in it, like magnesium, sodium, okay, silica, iron, sulfur, all these salts, which will be choking the tubes. And one thumb rule you need to remember always, 1 mm scale reduces 15% efficiency of an boiler. So if the scale goes on, the boiler is going to choke up, and sometimes this lead the boiler to blast. Sir, are all the professors present, or even the students are present over here?
So most of teaching faculty is from different branch of engineering, like mechanical, electrical, etc.
Okay.
All teachers, no students. Sir.
Okay. No, sir, I would like to hear from teachers also, because teachers are preachers. Because of them only we see, today we are teaching you, but because of you all people, we came over here, so that we are so much capable that we can make a gathering like this.
I agree with you, sir.
So you can further go on and ask me any question over here.
So what is minimum profit margins of this industry?
Yes, very nice, very nice. May I know who is asking this question, because I am not able to see the screen.
No, I am Hiral Badrakia, professor from
Okay.
BBIT.
Okay, sir. So see, when this whole process goes on, per ton of sugar, per ton, I say, the manufacturing cost, you can take it to around 20 to 25 rupees. Okay. So the sugar we get from outside, from the government, or we can say from the wholesalers, we get around 35 to 40 rupees. But that doesn't mean that the government is getting more money. The government gets a profit margin of around 5 rupees per kg. And that's not a huge margin, because 20 rupees they are investing over here. And the investment is been calculated in terms and with the help of farmers. Suppose the farmer sells the ton of a sugar cane for 2000 rupees. Now you can calculate what price the sugar cane comes. Per ton is 2000 rupees. 2 rupiah kilo. Correct?
Yes, yes.
So that is the 2 rupees costing. then comes the processing cost, then comes the chemical cost, then comes the transportation cost, which all sums up and goes to 20 to 25 rupees. But India has the biggest sugar lobby. All the politicians have their own sugar factories.
Yes, yes.
And they are minting money also, sir. Politicians.
Sir, see, I told you na, this is the best place to get money. You can get each and everything from here. आप चीनी भी बेच रहे हो, चीनी के साथ डायबिटीज भी जाएगा और साथ में दारू भी जाएगी. But this is the perfect example of a company which has each and everything integrated in itself. Nothing has been wasted over here. Even the waste is being used for the best.
Yes.
So the investment is less because there are many sugar factories in India. We are one of the largest sugar producer. After us, the Brazil comes. Before, Brazil used to be on the top. But in India, the thing is, we are not getting the pure sugar over here because the purest form of sugar is a brown sugar.
Okay.
And the white sugar has been a refined sugar, and we don't need to eat ultra high refined sugars because the more you refine the sugar, the more chemical content increase in it.
Okay.
And equally it becomes more harmful the more you refine.
Yeah, it gets more harmful. That's why in India only we are getting this white sugar. If you travel abroad in South Africa or East Africa region, they are using brown sugar itself. In Dubai, Singapore, US, Brazil, everywhere brown sugar. And one myth I want to clear, that there is no bone powder used in sugar to make it white. Never.
We had heard that it passes through that bones.
No, sir, never.
Okay.
The color precipitant, a polymer comes which is called color precipitant, which changes the color of the sugar. Again, the second thing. During clarification, SO2 gas is passed, sulfur gas, along with lime, which changes the color of the sugar. You must be seeing somewhere sulfur-less sugar. What is that? In that, SO2 gas was not passed. So this is a totally myth that the bone powder is being used for making the sugar bright. It's a wrong myth.
Okay.
We just came to know of this fact.
And this is a true fact because I am into this field since last 20 years. I have never seen this. Never.
Okay.
I want some more questions from the teachers.
Participants, you
Any
can
other
unmute yourself or you can write in your chat box. We can read it for you, for Nishant Sharma, sir.
Sir, Ashok Parmar sir has asked that please share your view for energy conservation and management in this industry as a general.
Sir, see, the energy conservation, what I was talking about, is been done on each and every step over here. Each and every step. We are conserving energy itself. The management is done by providing the proper operations in this industry. If you are operating boiler, evaporators and mills at proper system, because the mills are generally been forced by the electric power of the rollers. If you are doing a proper use of those things with the particular data that has been provided to each and every sugar industry for, आप लोग देख सकते हैं, as a manual has been provided, you have to work according to this manual. So in this way, the conservation is done. So from bagasse, the bagasse is again used as a fuel. The rollers, if we don't want to waste the sugar cane, that's why we are getting a fiberizer over here. So the extra scums get out. So the mills will be easily rolling. So if the mill rolls hard, then there will be issues of energy usage. The more the mills roll hard, the more the energy is used. Can you get me?
Yes, yes.
Yes, sir. Yes, sir.
Sugar industry is having their own power plant, so energy तो वो खुद ही पैदा कर रहे हैं सर. उनको बाहर से एनर्जी लेने की जरूरत ही नहीं पड़ रही. बस सिर्फ ये है कि they have to manage it by proper usage of the components that has been present in the sugar industry, like the heaters, the clarifiers, the evaporators, the boilers, and the distilleries.
But sir, all these instruments, they do consume a lot of energy, no? Boilers and heaters and milling train and all.
They do consume energy. Okay. See, 40 to 45% of the total mechanical energy is required is in the boilers and evaporators. The total energy, if suppose I'm making 100% energy in my power plant, 40 to 45% will be used in the process. The rest will be sold off. They required, but if each and every sugar factory is it's been done on the TCD, tons cane per day. Did you get me? Every day the crushing system is there. रोज कितना शुगर गन्ना कटता है और क्रश होता है उसके ऊपर जाता है. So according to that they will be maintaining. This is the management over here. This is the management word that comes over here, that how they maintain a 1200 TCD sugar factory and how they maintain a 10,000 TCD total crushing per day of the cane, TCD. So उसके हिसाब से वो लोग power plant लगाते हैं, उसके हिसाब से वो लोग components लगाते हैं. Again I told you one thing, that if you are using a proper channel and in a proper way, if you don't allow the mud to transfer to the boiler water, then there will be no scaling. And if there will be no scaling, you don't need a cleaning to the boiler. If there will be no cleaning to the boiler, there will be no shutdowns. A sugar factory generally does a shutdown every 45 to 60 days because they need to clean their evaporators and they need to clean their boilers. This is a basic thing, and for 2 days they clean it and again that works again. And one more thing, a sugar industry will never work a whole year. This is a 6-month industry. From October, or you can say from September end till April first week, the sugar industry will be working. Rest from April second week to August or September third week, the factory will be under shutdown. This is a thumb rule. Whether you are in India or abroad, this everything depends on the availability of the sugar cane. So in India, the sugar cane is available for 6 months. When you cut off it, it takes again 4 to 5 months to get to the height where did you cut it.
So practically every sugar industry will have shut down for 6 months every year?
Yes, sir. Yes, sir. Because 6 months it will be working and 6 months it will be doing the cleanup work.
Okay.
If I could have shown you the video, it would be better. But I don't know, the video is not able to be audible over there.
Sir, we can
I
see
will
the
share it with
video. No issue
Anurag sir,
about
so
audio.
that he can send it to all of you.
Oh yes, oh yes. Yeah, that would
No,
be
no, sir, but you need to listen to the audio also. Yeah, that will be more better for you. Let me try it if I can play it again over here because just a minute. Is it audible?
No, sir. No, sir.
It's not audible till.
no, sir.
Okay. Now let me do one thing.
Maybe time lag here.
I don't understand. Just a minute. Now can you listen to it? Was it audible?
Not audible, sir. It is getting interrupted, sir.
What, sir?
It is interrupted, not clearly audible.
Getting
Okay. Just a minute. Let me switch off my camera if I can. It's okay. Can you all read those subtitles?
Subtitles. Yes, 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 sir. It's fine.
So shall I start the video again or you want to read it from here itself?
No, sir, you can start from the first so that we can read it out, subtitles, and understand.
Yeah, just a minute.
Sir, it seems the video is also paused.
No, here it's running.
In our
It may
screen, it is
be,
not. In
I
our screen,
think,
it is paused.
because I think sometimes there is a. Yesterday also I was doing a presentation. Sometimes the the video is of very high quality, so maybe there will be a time lag
Okay,
or
okay.
the internet issues.
Hmm. Okay.
Okay, we can go further onto the slums slides, and you can ask me if any further questions you want to know all the things. Can you hear me?
No, sir, our video is paused at one particular instant.
That I have paused already.
Acha, okay, okay.
Yeah. Are you getting other slides?
No, sir.
Yes. Can you see me?
Yes, sir.
Now can you see the slides?
No, we can see your desktop.
You can see my desktop. You can see the slides.
Yeah, yeah. Now slide has appeared.
Okay. There is
Sugar
a time lag
process.
again.
There is time lag.
There is time lag. Correct. Okay. Now, sir, you can ask me something else if you want to know. In some other industries also you can ask me how they are conserving and managing the energies.
Participants can ask the questions and they can write in the chat box. No issue.
The more you will ask me the question, the more I will like to discuss it. Did you get me?
Yes, sir. The issue is we are comparatively new to this area. We don't know have much detail and knowledge about sugar processes. That's why maybe participants. Maybe
no.
that's why participants are not posing questions.
No, you need to ask something or other thing. Acha, you tell me all of what you all understand about energy conservation. Normal, a general topic. Anurag sir,
Yes, sir. Must say Hiril Bidrike, sir. Anurag sir is out of town, so is not present in this meeting, sir.
okay. And RD sir?
RD sir is also
And
busy.
then I am available, sir. Here I am available.
Okay, sir is
Yeah,
available
you
now.
are there, RD sir. So I think RD sir must have visited the sugar factory also.
Yes, once visited Pandwai Sugar Factory.
Pandwai Sugar Factory, correct.
Yes, yes.
Correct. So RD sir, you can also ask anything.
Uh, I think one question asked by Joseph Soni sir. I think,
Yeah.
and it is query related to me. But I think energy conservation and energy management is very much related in the sugar process factory, and various way in the sugar factory for the energy saving in the industry. So I think I have no any doubt regarding the energy conservation.
Okay, sir, let's do one thing, sir. We have more than 45 minutes left out for us. Let's discuss something. What are other industries? What they are doing presently for energy conservation? See, nowadays we all people get our the solar panels in our house. Okay, solar. We use solar system.
Okay, sir.
A
Yes.
very good example of solar panels and everything is Prairie, just opposite to BNB.
Yes, yes.
Yes.
They are doing a very nice work, a very good work for renewable sources of energy. Okay. So nowadays, you must have heard that I am also an iOS developer for Apple.
Yes, yes, sir.
Yeah. And in 2017, when I visited Cupertino in California, I was just astonished over there to see some different kind of HVAC. You must be knowing HVAC. I think the last lecture was on HVAC.
Yes, yes, yes.
Yes.
Heating, ventilation.
Ventilation. Yes.
Yeah. So a new kind of HVAC system I came to know over there. See, nowadays Facebook, Apple, Samsung, and all these companies, Facebook is now Meta. So all these companies, what they are doing, they are not taking power. They are using the olden techniques, the ancient techniques, to run the ACs or to run the system. Now, if you can see, I don't know if I will be able to show you. Just a minute. There is one slide. Yeah. Can you see this?
Yes, yes.
Yes.
Yes, yes.
Can you,
Yes, sir, we can see. No, we can
and
see.
can you hear it?
No.
Yes. Yes.
Just see on the roof. You can see on the roof. These are all solar panels.
Nishant bhai, some disturbance in your voice, not audible clearly. Sir.
Voice is not audible clearly.
Yes,
But the-
now it is okay. Sir.
Is the video stopped or it's playing?
No, it is stopped.
I have stopped it. I will start the video. Let the video complete and then I will be speaking.
Okay.
Okay.
Sir, video is not run. Sir. It is in post conditions.
I think there is some technical issue. The video is not running, sir.
I think there is issue. Actually, this time the issue is with Google Meet. Next time we will be doing it on Microsoft Teams.
Okay, sir. Okay. Definitely.
Okay. Now just look at the picture. Are you able to see the picture?
Yes.
Okay. I am pointing out. Can you able to see what I am pointing over here? Is the cursor being seen over here?
No.
No
No,
cursor.
sir.
No. At the left upper corner, sir. Your cursor at top left corner. Sir.
Means there is again a glitch over there. Let it be.
Sir, can I ask you one question?
Yeah, sir, two questions.
Is sugar factory producing ethanol for blending in petrol, or it gives molasses to other companies?
No, sir. Sugar factory is now about to give 30% ethanol for blending it with petrol. That will be reducing the cost of the petrol. But one more thing, which is in my mind, and which I always asking the automobile engineers. They are going to get the engines, and those engines will not be the original petrol engines. They will be the convertible engines. You know why? Can you hear me?
Yeah, we can hear you.
Yeah. Why they will be the convertible engines? Because, see, presently also in petrol we are getting 10% ethanol. You may be seeing at the petrol pumps 10% ethanol
Yes.
is added to the petrol. Okay. And for diesel, they are using biodiesel. There is a plant, I don't remember the name, from which they are extracting biodiesel. But that's not been so famous over here. But yeah, sugar factories are providing them with 30% of alcohol to blend with petrol. That is for true, and it's been about to start next year. Because यहाँ पे है ना, in India we don't need so much what we say rectified spirit. Actually, we don't need so much rectified spirit in India. We have surplus.
Okay.
And presently, even the sugar, we don't need to import sugar. We are exporting it. Okay. So, sugar को भी हमें इतना ज़्यादा बनाने का जरूरत नहीं है इंडिया में भी. So they are converting this plant because you can understand that during the pandemic last year 2020 they used to make sanitizers. All the sugar factory used to make sanitizers.
So one of my friend RB Varya sir, he wants to ask, is extra energy needed to produce ethanol?
No, sir. Ethanol is produced when molasses is being passed from a fermentation. We include the fermenter with yeast, and the same power plant which is been getting power from sugar industry is helping out the distillery to work. So external power is not required in sugar industry. A normal sugar industry can produce a power of 25 megawatt to a power of 85 megawatt. So that's enough for any of the company.
Thank you, sir.
So are you able to see any picture now?
Yes.
What's the picture? What's that picture?
Yes.
It's a big circular building.
Okay. Yeah. This
panels
is an
on top.
apple park. And can you see the plus sign rolling over the circle?
Yes.
Is it visible?
Yes.
Now you can see the panels on the circle. This circle, the panels are there.
Yes.
Okay. And over here, see, I am pointing one place. Over here, you can see the ducts are there.
Yes.
Okay. These ducts. These panels are the solar panels which provide energy to the total apple park. And the ducts, these ducts are there where you get the HVAC system installed. The water is flowing in a clockwise direction and the air is flowing in the anti-clockwise direction. And where does this air comes from? From the trees that have been planted inside this. So is it not a good idea of energy conservation and management?
Yes, yes, definitely.
They are not using any external energy. The pumps are being flowing by the help of the power produced by the wind.
Yes.
Nishant, it is just like a windmill, sir. But in the form of other forms, sir.
Yes, correct. Absolutely correct. But see, sir, there are two flows that we have studied in our, one is laminar flow and one is turbulent flow.
Okay.
So you all must have studied in your mechanical engineering.
Yes.
And the turbulent flow is the flow that has higher heat transfer rate.
Yes.
Correct?
Yes. Yes.
So this is one of the good example for energy management. They are managing and they are conserving all those things because see, 2030 is the plan of India and the world also to be carbon free.
Okay, sir. Okay.
Now tell me, sir, any further questions or anything else?
Yes, please. Any participants have a question, please can ask directly, unmute yourself or put in chat box, please. All the participants, please, if you have any query, you ask directly to the experts, please. Nishant sir, I think
You are done, sir, na?
no any queries from any participants.
So it was a great interaction with all of you and felt very good. After a long time, after almost 20 years, I have come with the professors, in contact with the professors.
Sir, definitely, sir. If it would have been an offline classroom,
Sir, surely I will be very happy to come and have an offline classroom with all of you so that we can interact more and more. Because on online, sir, sometimes, see, again, this is an online system. So we are not conserving energy, we are using the energy.
Yes, sir. Yes, yes.
So if it would be an offline,
Sir, we definitely continue that.
and my special thanks to BNB Polytechnic, RD sir, Anurag sir, and Aarti ma'am. And it was very nice that all of you teachers are taking so much initiates so that you can pass over it to your students.
Definitely, sir. Sir, you nicely encompassed all the aspects of energy conservation in sugar industries and distillation processes. And we wish that in futures you will arrange some, you can say that industrial visits regarding this sugar industries, if possible.
We will surely arrange an industrial visit. I have my plant near Naryad, in which we collect all the residues from food industry. You can say potato, chicory, food waste, then spent wash, press mud. Then again, you must have visited, when you visit to Ahmedabad, you must have seen the heap of that the debris.
Yes, yes.
Yeah, while going from the Narol way. Okay, So we are all getting collected those things to one of our plant in Nadiad. It's a huge plant in an area of 17 acres. And over there we are producing CNG from all those waste.
Oh, great, sir.
55% of CNG methane is been produced over there, which has been bottled and supplied to different industries for their gas requirement. And rest 45% waste that has been left out is been converted into fertilizer after 10 to 12 days. And those waste is giving us money.
Oh, very great, sir. Nice. Now, surely, sir, you will be contacted by the head of the department of BBIT Mechanical, and we will definitely arrange some industrial visit for the students as well as faculties. And those who is interested to know much about your plant will definitely
Thank you
contact
very
you,
much.
sir, for sure.
Thank you very much, Nishant Bhai. Thank you.
It's my pleasure, sir.
For a nice.
Thank you very much, sir. Thank you very much for giving me.
Most.
And we all come together and give back to the nature. What we are taking from the nature, we should give it back.
Yes, sir. Nice presentation
Sugar is
and
doing the same thing.
nice interaction with the participants and my faculty, sir. Very much, I am very much thankful to you, sir.
Thank you very much, sir. Have a nice day.
Special thanks to Nishant Sharma once again, sir.
Thank you very much.
Special thanks to you. You definitely told 3 types of
वैसे-
sugar and 3 things we came to know just after your lecture. Yeah, India जो है, it is the largest
Yeah.
manufacturer. Second thing we came to know जो हमारा मन में ऐसा myth था कि
Yes.
sugar passes through the bones, वो है नहीं. So that has been cleared. And one more thing that we came to know today itself after your lecture is that 1 mm of scale reduces 50% efficiency of the boiler. So this fact we were not unaware of. We were not aware of that.
Welcome.
So thanks to you, sir. And we will definitely continue our license with
Sure,
you.
sir. Any day. And
Thank you.
and one more thing that I have started my career in Vidyanagar, and still my parents stay in Vidyanagar. So if I get a chance when I come over there, I will definitely visit all of you and meet you in person.
101%. Most welcome, sir. Most welcome.
Yeah, sir.
Definitely, definitely.
Okay, sir.
Thank you very much, sir. Thank you.
Bye. Take care. And have a good day.
Thank you, sir.
sir.
Yes. Bye.
Sir.